Alright, we're going to do section 8.4. It's all about area of triangles, and there's two new formulas you have to memorize. So if you look at this box here, I know it's a little blurry on mine, but you have yours. The triangle area can be 1/2 side B side C times the sine of A, or excuse me, or the equivalent of the other ones. So what you want to notice in the first formula is you have each of the three letters. You have a B, C, and an AC and a B, an AB and a C. Alright, so what you need for that to happen is when you draw out the triangle, you should have a side angle side case so that you can use this formula. Now I will show you in class how to get around using that formula, so we can do it kind of the logic way as well. But if you're a good memorizer, the formulas come in really handy and they're really fast. Okay, the second formula down here we're going to use is when you have a side case and how to find the area. An important part of this is, this might be new to some of you, when you see that S, it stands for semi-perimeter. So think of perimeter as being the distance all the way around the triangle, semi meaning half of that perimeter. And then again, if you have good memory, this little formula here is going to come in handy and it makes it really fast. Okay, so let's jump in. Let's try a few examples. So if we look at number 4 here, it says number 4 because it's kind of a continuation of law of cosines. Number 4, and we draw the triangle out. Okay. And once you get good at these, you might not have to draw these out. Okay, so we have A, B, C, angle A, side B, and side C. So what you notice is I have one of each letter, a side B, a side C, and angle A. So that would be a side angle side case, which means I can come up to my formulas and grab one of the formulas. So if I have angle A, I'm going to be using this first version of the formula. So the area would be, so I can do this in one step, which is nice. 1/2 side B, side C, times the sine of angle A. Alright, check your mode, make sure you're in degrees, and if you punch that all in one step, we should get the area to be at 115.8. And they don't give us a unit, so we can say unit squared. Okay, so again, it's all in one step. But it is important to notice you do have to have a side angle side case to use this shortcut. All right, and again, I'll show you in class how to get around it if you want to see the long way too. Okay, let's do another one. Let's look at number 5. So if I'm looking at number 5, I start drawing it out. And again, you don't have to draw them every time if you notice you have one of each letter. But let's draw it. A, B, C. Side A is 1.8. Side B is 5.1. This time angle C is 112, so you can see I really haven't drawn it to scale here. 112 should be a much bigger angle. But still, the formula holds true. So if I use the formula, it's going to be 1/2 times side A times side B times sine 112. Okay, so all in one step in the calculator, I should get the area to be about 4.3 units squared. Alright, so there's quite a few problems like that to try in the homework on this section. And as long as you have one of each letter, an A, a B, and a C, you can use this formula. Now let's look at one where you're given all three sides. So again, you probably don't have to draw this out, but I will, so I can kind of talk about the semi-perimeter on this one. Alright, so A, B, C, A, little b, little c. Okay, so I notice on this one I have a side case. So I have to use a different formula. So the other formula on this sheet says this. The area is a square root of, it's kind of a big square root, the semi-perimeter, so half the total perimeter, times that same semi-perimeter minus one side, minus another side, minus the third side. So yes, it's another formula, but it's really not too bad. So if I do the semi-perimeter for this one, let's talk about the perimeter first. I would say 18 plus 13 plus 15. So I get for the entire perimeter, all right? And then if I cut that in half, that gives me the semi-perimeter, and I get 23. So this 23 is my S. Want to use that. Then if I look at the problem again, as long as I know the three side lengths, I'm ready to go into my formula. Square root, semi-perimeter is 23, and then that same number minus each of the three sides. Alright, so you can see the math isn't so bad as long as you have the formula right. Okay, probably all at one swoop in your calculator. We'll round to the nearest tenth again. We get about 95.9 units squared. Okay. All right, so you guys try example 7 on there and have that filled in for tomorrow. All right, the next few examples, they involve remembering a little bit of geometry. So if you're not quite remembering the shapes in geometry and how they work, maybe pop in and see me and I can help you out with that. Okay, so here's what number 8 says. Find the area of a regular octagon. Regular means equal sides, equal angles. Octagon, 8 of them. Inside a circle of radius 9. Okay, so let's draw this out and let's see what it looks like. All right, let's see how well I can draw an octagon here. Let's draw a circle first. Okay, yeah, it's all right. Okay, now the octagon inside, so 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so not the best picture. And if yours isn't so great, really don't worry about it. You'll get the big picture here when I draw a bigger triangle here. Okay, so the radius of the circle is 9. So when you draw your radius, the best place to draw a radius is going to be to one of the points on the circle and the octagon. Okay, so that's 9. And it wants to know the area of the regular octagon. Okay, so what you want to think about first, you might not need to draw all these in, but think about the idea that there are 8 triangles in here. So if I can find the area of one triangle, then I can go in and multiply that by 8. So if I look at the triangle here, or all the triangles for that matter, I have 2 sides. So if I can figure out what angle is right in here, I will then have a side angle side case, and I can use the formula that we just learned. All right, well, how do we find that angle? We take 360 degrees, and the reason 360 is because all the way around any circle is 360. So I'm going to take my 360 degrees, cut it into 8 equal parts, and I find each of these little angles in here would be 45 degrees. So that's 45. All of these little angles, the one I was looking for is 45. So now I fit my side angle side case. So when I start my area formula, I can say area equals 1/2, 9 times 9, sine 45. So that would give me one triangle. So if I take that, multiply it by 8, I get the total area. And again, to the nearest tenth, I get 229.1 units squared. All right, so you don't even really need the whole picture. So if you can't draw one, for instance, in example 9, you've got a nonagon, you don't really need to do that. You just need to know 360 divided by however many sides will give you the angle, and then the radius on both of them is going to be your 2 side lengths of the triangle. All right, so you guys try number 9, and then let's take a look at number 10 now. Okay, so back to geometry, parallelogram. So if I draw a parallelogram, it means 2 opposite sides are congruent and both opposite sides are parallel. Okay, has side lengths of 18 and 26. Now I just happen to draw mine so the 18's on this side, shorter side, 26. It doesn't matter where you put them. You could have put them on the reverse sides as well. And it says one angle is 39 degrees. Once again, it doesn't matter. Even though this one looks obtuse here, like a big angle, I could label that 39 if I want to. I'm going to go ahead and label this one 39. Okay, so now let's fill in a couple more angles. For instance, we know how to find this one, hopefully, because of the parallel lines. There are parallel lines here. So those two together should be 180. So that angle there is going to be 141. Okay, so I kind of have the side lengths filled in. Now it says find the length of the shorter diagonal. Again, you don't know which one's shorter. So if you were to do both, you could do it. So let's kind of do both and pretend we don't know if our picture is drawn to scale. We're not sure what's happening. Okay, so let's draw first. I'm going to draw the one going this way. Label it X. Alright, so if I have a side angle side case, and I'm looking for the opposite side, I should be thinking law of cosines. So it would look something like this. X squared equals, law of cosines says this. The 2 sides squared and added together, minus 2 times 18 times 26, cosine of that included angle there, so 39 degrees in this case. Okay, now, depending on how you enter it in a calculator, 1 step, 2 steps, however you enter it, we should get X to be about 16.5. Okay, now I'm assuming that's the shorter one, but let's just double check. Let's try the other one. So if I'm looking at the parallelogram, and I draw the diagonal going the other way, Okay, so let's look at this blue triangle this time. Right, it's going to be 141 in here. I know it's getting a little messy, but hopefully it's going to be okay. All right, so if I solve for that one now, let's call the blue side y. Y squared equals, same kind of setup here. All right, law of cosine, so get that memorized. Cosine 141. Again, all in one swoop. I should get y to be about 41.6. The question specifically says find the shorter diagonal, so I'm going to go with my first answer.